Disc Manufacturing Open House. We're here to celebrate today the pressing, the manufacture of our 10 millionth disc, which is Rocky III, of which I have a copy in my hand. The disc itself was manufactured several days ago, so we would like to share with you the manufacture of that disc on videotape in the form of a tour through our facilities. Although the operations are shut down today, during the period of this tour and every weekend, we must, to preserve the cleanliness of our environment in the manufacturing area, don a lab coat. It's required of every employee, every person entering our clean manufacturing area. In addition to the gown, which will require on all persons able to don one today, we must cover all hair with a hairnet prior to our entry into the manufacturing area. Air shower where all particulate is being blown from the outside to prevent carrying the particulate into the manufacturing area. Now we are on the clean side of the air shower. This is now the manufacturing environmentally controlled area. We'll approach the press floor as we move down this hallway. We see the press molds being prepared for the insertion of the stampers, which are manufactured in the matrix area prior to being mounted on the Videodisc press for disc manufacture. The compound enters through a special drying hopper into the press extruder where the compound is melted and extruded into a puck. Here is the puck being transferred and placed precisely between the two stampers. And now we'll see the press close on that puck and actually form the video disc. Here we see the disc in the trimming mechanism. We'll see the knife remove the heavy bark. Where it's discarded, the edge is routed to very close tolerances, after which the finished press disc is placed on a spindle for storage prior to the next part of the operation. Duplicate samples are taken and tested on our product electrical testing system, where all data regarding the playback are accumulated and form the basis for our product approval. After approval at this point, press runs are then moved to the finishing area, which we will visit next on our tour. The introduction of our product to the finishing operation. Each disc is visually inspected on each side for gross defects, deflashed on a brush mechanism or debris removed from the center hole. After loading, the discs proceed through a rinsing and a water washing operation, followed by drying, where they transfer from the rinsing portion of the operation to the lubrication portion of the operation. The disc receiving what is a lifetime lubrication. After lubrication on one side, the discs are automatically turned over, followed by lubrication on the reverse side. Following the lubrication, the disc is removed from the line and placed into our verification machine, where the title of the disc is compared electronically to the title that is on the caddy itself. Here you can see our 10 millionth Rocky III disc leaving the verification area. Here we are viewing the beginning of our caddy assembly operation, at which point injection molded caddy halves are mounted onto an automatic water washing device. After washing and air drying, caddy halves move automatically through an indexing device to the lip seal applicator. Here, the protective lip seal is placed on an automatic application head, which places it into the groove in the caddy half. Following lip seal insertion, the caddies are aligned for movement down the automatic welding assembly assembly part of the operation. After welding, parts are inspected for internal clearance and proceed for use in the labeling portion of the operation. The welded caddy assemblies are loaded into the feed mechanism, which is feeding our automatic labeling machine. The labels are fed, coated with glue, and automatically wrapped around the welded units and discharged at this end of the labeling machine. They go through a drying cycle on racks, after which we insert the internal spine and send them to the insertion area which we visited a few moments ago. But for those of you who are interested in seeing some of the other areas, we have provided videotapes for you to view in the employee rest area after the conclusion of your tour in the manufacturing plant. We're very pleased to have this experience to share with you. Our 10 millionth disc is a real milestone in the video disc manufacturing industry. We look forward to many more experiences such as this one. Please feel free to ask any questions that may occur to you of our guides who are stationed throughout the tour area. You can identify them by their red jackets. Thanks again for coming. Enjoy the tour and enjoy the rest of the picnic.
Videodisc Master, converting videotape software to videodisc hardware. Here in mastering, sensitive and highly technical processes transform the videotape and copper blank into a recorded master substrate from which many metal parts can be made. Before attempting to cut a master substrate, the videotape from Hollywood undergoes stringent quality examination. In the offline area, hundreds of technical measurements are taken to ensure compatibility with the process and to avoid recording defects from the tape to the master substrate. If needed, both the picture and sound may be enhanced in the offline area, and when a tape has achieved a high enough quality, it will be transferred to the signal generation and substrate recording area. Another key area in mastering is the cutter head operation, where under microscopes each cutter head is handcrafted. With fine precision, barely visible diamonds are mounted to miniature piezoelectric transducers, wired with pure gold wire finer than hair and connected to other components. Each step requires testing to ensure the quality of the cutter head. For the finished cutter head, we'll move the diamond up and down 3 million times a second. With nearly absolute precision, it carves 12 miles of grooves in the copper substrate so tiny that 40 of them would fit on the thickness of a human hair. And this is not a job that the cutter head will do only once. The completed cutter head will perform this task many times before being returned for recycling in this area. Around the corner, the copper substrate blanks are prepared. Using complex and highly specialized equipment in a temperature-controlled environment, the blank is made flat to within 1 micron over 14 inches. And then, the barcode and stamper alignment grooves are recorded onto that blank. Next, it will be reviewed using a laser interferometer, and when approved, information needed to track the metal parts and video disc throughout the production cycle will be added. The approved tapes, blanks, and cutter heads join here in the central activity of signal generation and substrate recording. To produce a master substrate, the efforts on both sides of this wall must be synchronized, and the process monitored closely during recording to yield the quality masters required. Once a master substrate has been cut, it will undergo a series of quality evaluations using equipment as sophisticated as that used to produce it. The final test is a 100% evaluation at this laser playback test station, ensuring that the quality of the recording is acceptable for making video discs. After passing, the substrate will be transferred to the matrix department for the fan-out of the metal parts. The first discs produced from a new substrate are called proof discs, and these are reviewed on RCA video disc players and TV receivers for a final check of program quality by members of the mastering organization. Mastering, a blend of talent and technology, where engineers and technicians and Hollywood entertainment meet to create the master parts which ultimately put the video disc program in the consumer's hands. Matrix operations. Here, through electrochemical processes, the delicate substrate is duplicated into metal parts durable enough to withstand the pressing of thousands of video discs. In these plating tanks, pure nickel is dissolved and electrically driven over to the parent part. The parent part has been specially treated to allow the nickel plating to be peeled off, creating a perfect mirror image of the parent. The process and chemistry are constantly analyzed by technicians to maintain precise plating conditions. Because of the cost, difficulty, and ease of damage, the copper substrate parts are fanned out here. This is a graphic illustration of the fan-out. In this example, one substrate could be plated 5 separate times, and each time a master would be peeled off. Those 5 masters would each be plated 5 times so that 25 mother parts are produced, and each of the mother parts could be plated 5 times, potentially yielding 125 stamper parts, each one capable of pressing hundreds of video discs. Air, water, and material purity are critical to disc manufacturing, and therefore all matrix employees wear lab coats, hairnets, and enter through an air shower to preserve the environment of the metal parts. Spit masks are worn in all areas where the face of the part is exposed, as the moisture and breath could damage its surface. Rubber gloves are worn by all platers to protect them from the plating chemistry and protect the parts from oil and fingerprints. Duplicating the microscopic detail of a metal part involves some of the most sophisticated electroforming ever performed. Operators meticulously follow a precise sequence of washing and treating parts prior to beginning the plating cycle. The matrixing of metal parts began in the phonograph records industry. The sophistication, though, of the video disc required advancements which have redefined the art of metal plating. Great care is taken throughout, as this process can duplicate so perfectly that any even microscopic debris or stains will transfer from one part to the next. When the plating cycle is completed, the part will be washed and dried in solvents to prepare its way for separation, where skilled operators will peel the child away from the parent part without distorting either part. Then they are identified, labeled, and transferred to first inspection, where the plating and separation quality are evaluated and any suspected defect examined under a microscope to determine if it is a problem, so that the status of the part may be entered into the DMAX computer system. Approved parts are then laminated with a protective film before beginning the finishing cycle, where the back of the part will be polished, and then it can be precisely centered, punched, and coined, so that they can be mounted onto a video disc pressing mold. The part then receives a final inspection before being sent to the vault, where they will be stored until needed for pressing video discs. Video disc matrix. The faithful reproduction of master metal Compound. The Videodisc compound, the plastic material of which the video disc is formed in pressing. Here at Rockville Road, powdered ingredients are compounded into Videodisc plastic. Years of research have yielded precise formulations, specifications, and methods. Behind the main plant, a new compound facility nears completion, and this should optimize these efforts. Miles of stainless steel, power and control wires, state-of-the-art machinery are the vital organs of this operation that will ensure that pure and consistent compound is delivered to the press floor. From these stainless steel silos, polyvinyl chloride powder and carbon powder are transported indoors. Minor ingredients are added to the system here through these automatic loading stations, which sweep dust off of the bags at the bottom, convey them to the top, separate automatically the bags from the ingredients, and dispose of the bags outdoors through a compactor. Then, utilizing the latest technology, the material these bags contained is conveyed with the purest possible air to bins 60 feet up in the air, and from there, all the ingredients are gravity fed. On the floor below, precise weighing and scaling systems from which the dry ingredients are fed to the high-intensity mixers, which is the step directly before feeding this dry blended material to the extruders, which will create the plastic pellets. These pellets are formed at the press into the familiar puck. In this plant, every conceivable precaution has been taken to avoid leakage into or out of the system. The new facility reflects our growing knowledge of Videodisc compounding. The precision weighing, conveying, cooling, and temperature steps are all fed back to the computer control system, and this helps to provide a competitive edge in the manufacture of a plastic like none other. For this material must, under the heat and pressure of pressing, form perfectly. Hundreds of trillions of bumps that are less than millionths of an inch in height, and after the disc has cooled, retain that form indefinitely, enabling the stylus to read over 100 million signals per second. The Videodisc is a challenging product, and it is a challenge to produce a raw material with less than 0.006 of 1% contaminant. But it is a challenge met by RCA and those involved in compound development and manufacturing.
Hello, I'm Eric Bennett and would like to welcome you to the Rockville Road Plant Picnic and the celebration of the 10 millionth disc. One of the areas you'll be unable to see today is that of the stylus cartridge manufacturing area. What I would like to do on behalf of the manufacturing people, the engineers, scientists, and technicians of our cartridge family would provide you a picture tour of our area where we manufacture this Videodisc cartridge, which is placed in the player and picks up the electric signal from the disc, which is then displayed on your screen as a picture. This is a panoramic view of the main manufacturing area, looking across through where the cartridge is assembled, through the micromachining and electrical test, and in behind the tan cabinets is the main pack area where the cartridge is finally packaged prior to shipment. One of the first steps in the manufacturing of the cartridge itself is one of the sub-assemblies where we insert two magnets in a tube with a stylus holder. This machine was designed and developed by our engineers and designers here at Rockville Road. It was assembled by the Dressler Manufacturing Company in Bargersville, Indiana. This operation assembles the pickup arm, the subassembly, which we'll see later when we pierce the diamond. The diamond is faceted here on a scape using pencils. The diamond we use is called a half log and is about the thickness of a human hair and about twice as wide. These pencils hold these diamonds, and the operation you see here is the side facet. And the diamond comes down on the scape and is machined on a plate which is rotating about 4,000 RPMs. Once the diamond has been faceted and inspected, it is then brought down to the stylus piercing, where we pick up that subassembly for the pickup arm, and we pierce the diamond through the holder. Here you see the operator inserting a pickup arm subassembly and piercing a hole where the diamond will go through. The next step is inspecting the extension of the diamond, which you'll see in the optical comparator. This checks the angle and the extension of the diamond through the holder. Another subassembly is where we attach the rivet and the fly lead with solder. There's a solder paste put on, and in this operation heats the head of the rivet and reflows the solder around the fly lead. This will later be assembled into the final cartridge. This operation where they stake the rivet, which is in this container fixture, and then we put a cartridge case in and come down and stake the rivet into the cartridge case. Next operation is installing the rubber suspension in the rear. This will hold this pickup arm assembly. The cartridge case with the fly lead is next exposed to what we call the B fixture, where we pick up the pickup arm subassembly with the diamond, and we finally put all of these subassemblies together into a cartridge. What you see the operator doing here is putting the fly lead over the diamond and then applying some silver epoxy to the end of the top of the diamond. While the silver epoxy is drying, we put a clothespin, which is what she just put in, and then we let it sit overnight to dry. After the final assembly, it goes to micro machining, where we put the final small tip on the end of the diamond. This is a microprocessor controlled mechanical piece of equipment. The operator looks at the shoe of the diamond, which rides in the disc, and inspects it for completeness and length. And then she feeds information back into the machine on these parameters, and it'll adjust the machining time, so we are able to get a cartridge which is then moved over to the automatic testing line, which is again is a computer controlled piece of equipment where we do electrical test and then a scan performance test. This machine was totally designed and built by the engineers within our organization here in Carthage, Rockville Road. As you can see, it picks a cartridge up, inserts it into the testing module, tests the cartridge. When it's finished, an arm goes and moves it over. Here you'll see before your eyes a growing stylus as we come in on the final tip. This is the only way we can really see the final shape of the diamond shoe, is through use of this microscope. This wraps up a quick overview tour of our area. I'm glad to have you with us, and hope you have a good and wonderful day.
I want to welcome you all to the 4th annual family picnic here at Rockville Road. Don't really have much to say except to enjoy yourself, and you've achieved a fantastic goal, having started in 1979 with nothing, coming to product in March of '81, having made the 5 millionth disc in June of 1982. We're now standing here with 10 millionth disc having made in this plant. It's a major achievement for the organization, and there's a fellow here in town that's been helpful to us from the very beginning. His name is Bill Hudnut. He's been out here at least 4 times. He's written letters for us to our new people, welcoming them to the community, and he's been a real supporter, and I want to thank him personally with a little presentation, a gift of the 10 millionth disc. The presentation is of a plaque, and it reads, "In appreciation for your support, the Honorable Mayor William H. Hudnut III, 10 millionth video disc, June 1983. Bill, thank you for your help.
Thank you very much, Doctor. It certainly is a pleasure for me to be here and to let you know that the city of Indianapolis is very, very proud of the fantastic production record here at Rockville Road. And we take our hat off to you, and we salute you, and may you have 10 million more. Thank you very much. I'll treasure this always. In case you're wondering what it is, it's Rocky III.